Red squiggles everywhere, your build is broken, and the error message reads like another language. Here's the good news, TypeScript throws the same handful of errors at almost everyone, over and over. So in this video we fix the 10 you will actually hit in real projects. For each one you get the exact message TSC prints, why it fires, and the 30-second fix, shown as real code. Let's clear your problems tab. Before the 10, one skill unlocks all of them, how to actually read a TypeScript error. Learn to read one, and you can read all of them. Every message has the same 3 parts. First, the location, the file, the line, and the column, so you know exactly where to look. Second, the error code, like TS2322. That code is stable, so you can paste it into a search and find the same problem other people already solved. Third, the message itself, in plain English, telling you what TypeScript expected versus what it actually got. Here is the real trick, read the message backwards. The last few words are almost always the actual problem. Take, type string is not assignable to type number. Read from the end, it wanted a number, you gave it a string. That's it. The whole error, decoded in one sentence. One more thing. TypeScript errors often come in a little chain, a main error followed by extra notes that add detail. Read the first line first, the notes are just supporting evidence. Get comfortable scanning location, then code, then message, and honestly half of your debugging is already done before you change a single line. Error 1, TS2322, the one absolutely everybody meets first. Picture it, you declare a variable as a number, then somewhere you hand it a string. Maybe it came from a form input, or from JSON, where everything arrives as text. TypeScript stops you cold and says, type string is not assignable to type number. It fires for one reason. The value's type does not match the type you promised in the annotation. The fix is almost always to make the value match the type. If you genuinely meant a number, drop the quotes, or parse the string with number or parseInt. That's the honest fix, because now the value really is a number. But sometimes both types are legitimately valid. A field might hold a string on one path and a number on another. In that case, widen the type on purpose to a union, number or string. Now both are allowed and TypeScript is happy. The one thing you should not do is reach for any, just to make the red line disappear. That throws away the exact protection you turn TypeScript on to get. Error 2, TS2339, property does not exist. Here's the scene, you create an object with a name, use it happily, then later reach for .age. TypeScript says, property age does not exist on type. Notice it even prints the exact shape it inferred. The reason is simple. TypeScript only knows the shape you actually gave it, and age was never part of that shape. There are 2 honest fixes, depending on the truth of your data. If age really does belong on this object, then add it to the interface or type that describes it. Now TypeScript knows about age everywhere, and you get autocomplete for it too. This is the fix 90% of the time. The second case, the property only exists sometimes, on some variants of the object. Then narrow the type first. Check that the property is there, or check which kind of object you have, before you read the field. Inside that check, TypeScript lets you through safely. What you should not do is cast the whole thing to any just to grab a field. If the field is real, describe it. Error 3, TS2564, no initializer. This one is class only, and it catches people off guard the first time. You write a class with a property, say name of type string, and you don't set it right there. TypeScript says, property name has no initializer and is not definitely assigned in the constructor. Under strict mode, strict property initialization insists every property genuinely gets a value, so it can never be undefined by surprise. 3 fixes, best first. Best of all, actually give it a value. Assign it inline where you declare it, or set it in the constructor. Now it can never be missing, which is the whole point. Second option, maybe the property really is optional and might not exist. Then say so, with a question mark after the name. Its type becomes string or undefined, and TypeScript stops asking. Last resort, the definite assignment operator, a bang right before the colon. That tells TypeScript to trust you, because something outside the constructor sets it. Only reach for that when a framework, like Angular with its injected properties, assigns the value for you. Otherwise, prefer a real initializer. Error 4, TS2304, cannot find name. You reference document, and TypeScript says, cannot find name document. Plainly, this identifier is not in scope, and TypeScript has no idea what it is. The useful part is that there are only 3 causes, and the fix depends on which one you're in. Cause 1, it's your own code, or a package you installed, and you simply forgot to import it. The fix is the import line at the top. This is the everyday case. Cause 2, it's a real library, but it ships no type definitions. The runtime code exists, but TypeScript is blind to it. The fix is to install its types package, @type/the library name, from npm. Cause 3, and this is the sneaky one, it's a built-in browser global, like document or window, and your tsconfig doesn't include the browser library. The fix is to add DOM to the lib array in tsconfig. 1 error code, 3 different routes, but the message always tells you exactly which name it can't find, so you know the cause. Error 5, TS2554, the wrong number of arguments. You define a function that takes 2 parameters, then you call it with only 1. TypeScript says, expected 2 arguments, but got 1. It literally counts them for you, and it counts too many arguments the same way. 2 fixes, and which one is right depends on intent. The obvious fix, you just forgot an argument, so pass it. Done. But very often that second parameter is genuinely optional. Maybe it's a config flag most callers don't need. Then say so in the signature. Mark it optional with a question mark, or give it a default value with equals. Now a call with 1 argument is completely legal, and callers who need the second one can still pass it. Quick aside, want all 10 of these errors as a printable cheat sheet, with every copy-paste fix in one place. My TypeScript Mastery Pack has exactly that, the link is in the description. Totally optional. Now back to the errors. Error 6, possibly undefined, the one that quietly saves you from crashes. Classic setup, you call find on an array to locate a user, then immediately read a property off the result. TypeScript stops you, user is possibly undefined. That's TS18048 in recent versions. Its close cousin is TS2532, object is possibly undefined, which you'll see on index access and similar spots. And TypeScript is completely right. Find returns undefined when nothing matches, so that property read could blow up at runtime. This is strict nullchecks doing its actual job, catching a crash before your users find it. Fixes, fastest first. Optional chaining, user, name. If user is undefined, the whole thing is undefined instead of throwing. Second, a nullish default, read the value, then double a fallback, so you always get something usable. Third, an old-fashioned guard, if user exists, then use it inside that block, where TypeScript now knows it's defined. What you should not do by reflex is slap on the non-null assertion, the bang. It just tells the compiler to be quiet. It proves nothing, and if you're wrong, you get the exact crash the error was warning you about. Error 7 is a different animal, it's a runtime error, not a red squiggle. Your code compiles perfectly, ships, and then explodes in the browser with, cannot convert undefined or null to object. Because it's a runtime crash, TypeScript never warned you, which is what makes it sting. Where does it come from? Almost always object.keys, object.entries, or object.values, called on something that turned out to be null or undefined. Spreading null into an object can do it too. You expected an object, you got nothing. The immediate fix is to guard or default before you touch it. Guard, if not obj, return early, and skip the whole block. Or default inline, object.keys of obj, empty braces, so a missing value becomes an empty object and keys just returns an empty list. But here's the lesson that matters more than the patch. The real bug is almost always upstream. Ask where that null actually came from. A fetch that failed, a key that wasn't there, an API that returned nothing. Patch the crash so it's safe, then go fix the source, so it never arrives null again. Error 8, TS2353, the implicit any from indexing. Setup, you have a plain object, and you try to read it using a string variable as the key, maybe from a loop or user input. TypeScript refuses, element implicitly has an any type because expression of type string can't be used to index type. Underneath, it's saying, I can't guarantee an arbitrary string is a real key on this object. So the result would secretly be any, and no implicit any forbids that. 3 fixes, pick by how open your keys are. First, add an index signature to the type, key, in square brackets, :string, mapped to your value type. That tells TypeScript any string key is allowed, and returns that value type. Second, and cleaner for a pure dictionary, model it as a record from string to your value type. It means the same thing with less noise. Third, if the set of keys is actually fixed and known, don't open it up. Constrain the key instead, typing it as key off that object. Now only real property names are accepted, and you keep full safety. Open keys, use a record. Closed keys, use key off. Error 9, TS2345, argument not assignable. At a glance it looks just like error 1, but it lives in a different place, and knowing the difference speeds up your fix. Here, you passed the wrong type into a function call. You've got a function expecting a number, and you hand it a string. TypeScript says, argument of type string is not assignable to parameter of type number. The fix is the same core idea as TS2322, make the argument's type line up with the parameter. Convert it, narrow it, or fix wherever that value came from, so a number reaches a number. Here's the distinction worth memorizing, because it tells you where to look. TS2322 is an assignment error, you're putting a value into a variable or property, and the types clash. TS2345 is a call error, you're passing a value as an argument, and it doesn't fit the parameter. Same root cause, a type mismatch, but 2322 points at an equal sign, and 2345 points at a function call. Read the code, and you know instantly which one you've got. So there are your 10. Now step back and notice the pattern. Most of them, the not assignable pair, the possibly undefined one, the implicit any one, come from a single setting, strict mode. Turning on strict true in your tsconfig flips on a bundle of checks at once, strict null checks, no implicit any, strict property initialization, and several more. And here's the reframe. That flood of errors on a strict project is not TypeScript being difficult. It's TypeScript catching real, shippable bugs, the null crashes and type mix-ups, before your users ever hit them. Every red squiggle you fix today is a runtime error that will now never happen. So my one strong tip, turn on strict from day one on every new project. When it's on from the start, you fix these tiny issues as you type, and it costs you seconds. Bolting strict onto a large, loose codebase later is genuinely painful, hundreds of errors at once. Start strict and stay strict. Quick recap of the skill under all 10, read the message backwards, note the code, jump to the location. That alone solves most of them. If you want all 10 on a printable cheat sheet, with every fix ready to copy, grab the TypeScript Mastery Pack in the description. The full written error guide is linked right beside it. Subscribe for more TypeScript, and now, go clear that problems tab.